Hey there, home labbers and engineers. FE Engineer here. So recently I made a video talking about how to get up and running with a home lab with, different hardware as well as cloud providers, mostly aimed at ones that are 100% free forever. But so you might say, all right, great. I want to start up a home lab and now I know how I'm going to do that, what hardware I'm going to run on, or that I'm going to run in the cloud for free. Great. Now, what should I do with it? So this is going to be some examples of different things that you can run. The first thing when setting up a home lab is that you will likely want to run what is called a hypervisor. A hypervisor is effectively like an operating system, kind of like Windows or something like that, that is capable of giving out hardware to different systems. So you might say, well, I have a full-blown server. It has 50 cores, and I want to set up a Pi-hole, but Pi-hole really doesn't need a lot of resources. I don't want to give 50 cores to run Pi-hole. I only want to run it on 1 or 2 cores. I only want it to have 20 gigs of hard drive space. I only want it to have 2 gigs of RAM, because that's frankly plenty for Pi-hole. That's more than what it needs. And so Proxmox is a hypervisor that will allow you to create a virtual machine. And you may notice the word virtual machine gets used a lot. It's exactly what cloud providers do. You go and get a VM with this many cores, this much storage attached to it, this much RAM. Proxmox does that exact same thing, but it does it on your home hardware. And Proxmox is free to use. It is, I believe, open source. And there are enterprise features for it, which you have to pay for, but frankly, the vast majority of people will never need that. And it works really well as a hypervisor, and it supports an awful lot of hardware and things like that. So things like NVMe drives and things like that run just great on Proxmox. I use Proxmox on my bigger server. My smaller server actually still runs ESXi, and I'm in the process of moving it from ESXi over to Proxmox anyway. But I cannot recommend Proxmox highly enough. If you have enough cores that you want to separate all of your services out into VMs, Proxmox is a great solution for that. If you had something smaller, maybe like a Raspberry Pi, or maybe something like a consumer grade computer, so not truly a server, or you had potentially some cloud services and you just wanted to lump them together, like with Oracle Cloud, which was in my last video about this stuff. Oracle Cloud will let you make one server that is running 4 CPUs and has a decent amount of RAM and a decent amount of hard drive space. But maybe for something like that, Proxmox doesn't really make sense, but maybe something like Portainer does. Portainer effectively is kind of like a hypervisor that runs Docker containers. And so with that, you can have a bunch of Docker containers up and down and running and not running. And so you can effectively give your VM, your virtual machine, a bunch of little virtual machines that are all, Docker containers. And so they're nice and isolated. And so Portainer is a way to manage all of that. And you can update containers and images, and you can stop a container and then start a different container. Portainer is a great way of doing that. I don't love Docker personally, so I don't really use Portainer, but I know an awful lot of people absolutely love Docker, and Portainer is a great way to manage all of that. When setting up a home lab, especially for the first time, or when you have hardware that you are unsure exactly what you maybe want to do, one of your very first stops should be this GitHub called Awesome Self-Hosted. This is a enormous collection of different software that is generally speaking free and is for self-hosted, so for home labbers and things like that. And you can see the table of contents here: software, analytics, automation, backup, blogging, booking, communications, conference, DNS, e-commerce, I mean, the list is enormous. And then you say, well, okay. And then you start to look and you say, well, analytics right here, there's, I don't know, a dozen, almost 24 different analytics software things that you can run. Okay, well, digital archiving and preservation. All right, there's another dozen. There are a bazillion choices. There is so much stuff to take a look at that when you're running a home lab or getting started, or you're at a point where you have a lot of excess hardware maybe, but you aren't sure what to do with it, Awesome Self-Hosted is a really good spot to go and say, hey, I was thinking about doing media streaming. I wonder what a good way to do that is. And take a look through here. And of course, check out Reddit and things like that, see what other people are doing. But this is a great place to get ideas for things that maybe you could or might want to do. So now that we've figured out how we're going to run stuff, what are some ideas of things that we can run? Well, probably the simplest and the old school tried and true, well, set up an ad blocker using Pi-hole. And not only that, install Unbound and turn it into a recursive DNS service. That way you can use that as your DNS providers, block ads automatically. And Pi-hole requires very little hardware. One CPU is plenty, one thread, as well as, I think, 256 or 512 megabytes of RAM is really all it takes, and a couple gigs of hard drive space is plenty. Pi-hole is a very easy to use system to set up. It is very stable, and you can run this on cloud servers, as well as you can run it locally. Pi-hole is a great place to start. Similar to Pi-hole, if you wanted something else that is very, very simple to get started, and if you were into cryptocurrency, Presearch nodes. Presearch nodes are about as demanding as a Pi-hole. Really, one CPU core is plenty. A couple megabytes, 500 megabytes of RAM or so, maybe a gigabyte. Very little hard drive space. And what Presearch is Presearch is a search engine kind of like Google, but because it's on a crypto chain, you're not giving your information to a company like Google. Personally, I use Presearch. I really like Presearch. And I run quite a few Presearch nodes. And now with Presearch nodes, if you're into cryptocurrency, you can stake your nodes and then you will gain pre-tokens as a payment for running these Presearch nodes. As a very simple thing, with Oracle Cloud, you can get 4 vCPUs. And so you can run 4 VMs, all attached to IP addresses. And so with Oracle Cloud free, you can actually run 4 Presearch nodes at the same time. And again, if you're into cryptocurrency, you can stake them, and then you can have 4 Presearch nodes for free running Presearch that you will gain cryptocurrency off of forever for free. So that's another easy example. And running a Presearch node is just a Docker container. So it is pretty much as simple as running a Docker container and getting it up and running. And that's it. There's no complicated configuration or anything. And it effectively powers a Google-like search. Again, I use Presearch as my actual search engine, and I've found it to be awesome. So some things that maybe aren't as lightweight as Pi-hole and Presearch. If you wanted file storage, you can go ahead and set up Nextcloud. Nextcloud provides a lot. It is way more than just file storage. But again, if you were running like on the Oracle Cloud with 4 vCPUs and 200 gigs of free hard drive space, you could set up a VM to run Nextcloud, have 200 gigabytes of free storage forever that you can just use to back up photos from your phone. You can also invite multiple people to it, and multiple people can have free cloud backup storage. As well as Nextcloud is really meant to be a platform that enables collaboration. You can have video calls on it. You can share files and collaborate, things like that. Nextcloud is free and open source. It's great. I use it. I allow my family to upload all their photos from their phones to Nextcloud so that there's a backup. But there's lots of things you can do with it. Nextcloud is not the easiest thing to get up and running. I do have a guide that shows you exactly how to run Nextcloud and how to set it up really, really efficiently. But so that's one potential thing you could do. Another thing, set up a Minecraft server. If you have kids, Minecraft servers are pretty easy to set up, pretty easy to run. I do, in fact, have a guide that is a little bit older, but it is the simplest way to set up your own Minecraft server. Again, you should be able to run it on Oracle Cloud with no problems at all. You can obviously run it on your own hardware as well. It isn't super demanding, but it is a little bit demanding. Either way, if your kids wanted to be able to play together on a Minecraft server, like, this is a very straightforward thing to set up, and will get you going on your home labbing journey. Along with setting up game servers, you could set up a voice over IP server. If you don't want your children on things like Discord, or if you don't like things like Discord, and you just want a very simple, straightforward voice over IP chat, Murmur and Mumble are a great way to go. I run Murmur servers on my home hardware. I've run them for years, and when my friends and I are gaming together, we all jump into Mumble. Mumble is the client that runs on your computer. Murmur is the server that coordinates and allows everybody to talk together. This is very old software, but it is very stable and it works really well. It's very low latency. It doesn't take a lot of CPU or processing power or anything like that. Murmur's great. That's a really, interesting and fun project to set up and run. Of course, you can just set up a web server. And you could use Apache, you could use Nginx, you could use Node, you could set up, any sorts of React projects from GitHub and things like that. But this is just an idea of course, if you have a server up and running, you can, of course, serve web content. Outside of that, if you were more into AI, Ollama runs CPU only. And I've run large language models CPU only and had them be incredibly slow and effectively unusable. And I was like, well, that is nice, but, kind of useless. Ollama seems to be different. I've run it on my local CPU, which is a very fast CPU. But Ollama generates tokens per second, meaning that even running locally, even running CPU only, it's able to provide responses in a reasonable time frame. It's very easy to set up. It's very easy to run. I don't know how well it will run on cloud or on servers, but it is something that I am actually testing out now on my home server. And so I'm going to figure out how it runs when you give it like 4 CPU cores. But if you wanted to run your own large language model and you wanted to run it in the cloud, this is potentially a good project to do that's really easy to set up, and you can configure a bit to run a model that you like. And if you don't like that model, then you can trash that and just run a different model. But Ollama is where it starts to become reasonable to potentially run some AI stuff on cloud hardware without costing a fortune, and potentially being able to run it on free cloud hardware and being performant enough that it's really usable. So Ollama is definitely something you could potentially look at running either on your own server or in the cloud. And then some other things to potentially look at for home labbing. Plex, it's not something I particularly like telling people they should do, but if you wanted to rip DVDs, store them, and be able to run them and share them to family and friends, it's really hard to recommend anything over Plex. It's well built, it's well supported, it is constantly getting updates, and it's stable. It works really well for doing this, and so Plex is a very, very real, usable thing that you can set up. And of course, you can connect to Plex on Roku and things like that. I have a Plex server. I've ripped almost every single DVD and Blu-ray that I own. They now sit on my server and they are available on Plex. So Plex is a very useful thing to run yourself and to potentially share out to family and friends. Outside of this, with all of this servers and hardware and things, you may be concerned about security. Well, OPNsense is a really, really well-built, well-documented way to set up, security for home labs and home networks and things like that. I happen to use UniFi as my hardware for my networking, and UniFi has a really, really great firewall and security and things like that. So I do not personally use OPNsense. However, if you happen to troll Reddit forums and you see an awful lot of home lab type stuff, you will see tons of people run OPNsense. So this is a very good project to potentially play around with, set up on your home lab, run your computers and stuff like that through. And it is free and open source. It is well supported. It is well documented. OPNsense is a great thing to run on your home lab and ensure that your home lab is protected from, intrusion attempts. Because of course, whenever you open up your home lab to the internet, there is the very real potential chance that people could try to hack you and things like that. And generally speaking, when it comes to hacking and stuff like that, all you need are a few layers of security running reasonable settings. And generally speaking, that is enough to deter virtually any hacker. They go for the easy, low-hanging fruit. They don't typically spend a lot of time trying to hack into anybody in particular, especially if it seems like the person has spent, more than 20 minutes trying to make sure that they are protected. So OPNsense is a good layer to have in that security for your home lab. So in the last few videos, we went over a couple different things of how to get reasonable home lab hardware. Some ways to run your home lab entirely in the cloud without paying anything. We've also looked at, if once you get some home lab hardware, what should you be running on it? Do you want to run Portainer and have everything running on Docker containers, okay, well, that's a reasonable route to go. Do that. If you want to run things as actual VMs and they have their own hardware relegated to them, their own CPU cores and hard drive space and stuff, great. Proxmox is a great way to do that. And then once you determine what hardware you're going to run and get that, and you get some sort of effectively a hypervisor set up and start running that, great. Now it's time to choose what you're actually going to start. And, starting pretty easy, Pi-hole and pre-search nodes, super simple to set up and really powerful and useful things. So, go ahead and run those. And then quite a bit of other stuff of gaming servers, voice over IP servers, file servers, and collaboration software, running your own web servers, running, cloud-based or server-based AI models. Great. Sharing out your old DVD and Blu-ray library with family and friends and stuff. Great. Use Plex. And then securing stuff out with OPNsense. We've looked through quite a bit of stuff, and this should give people really solid directions of if they wanted to start a home lab, how to go about doing it from start to finish. These are some examples and ideas. There are a million other things that you can potentially do. With Raspberry Pis, there are a billion different projects and things that you can run. So I hope this has helped some folks, and I hope people have found this useful. Thanks so much for watching. Have a great day. Thank you so much for watching my videos, home labbers and engineers. I create and edit all of these videos on my own, so any likes and subscribes will massively help out the channel and allow me to continue creating content to help people. If you got value out of this, please consider liking and subscribing to the channel to be notified when new content drops. If there's something I've not covered but you would like to see a video on it, please leave a comment down below. And again, a massive thank you to everyone. I hope you have a great day.